Okay, so this screen is about any unusual requirements with redistribution with respect to the routing protocols. So let's start with RIP. Well, the first really unusual thing with RIP is that it won't send any routes at all without an export policy, and this is different to the other protocols. The reason for this is really quite clear. RIP uses hop count as a metric. Now, a single hop can be a very long way away, so hop count as a metric always has inherent issues. You could have several hops just in and out of a VMware stack, and the data could be very closely located. So for this reason, RIP isn't the cleanest protocol to use, and because of that, it won't send any routes unless you explicitly put in the export policy. Okay, how about OSPF? Well, with OSPF, we have a different type of issue. OSPF is using flooding for the route propagation, and it has a topological database. Now, because of that, the topological database and the INET0 really are very well connected. They're connected in. Now, what that means is you can't have an import policy from the topological database into the INET0 because the routes are being placed there using the protocol standard, and you can't just filter them on a per box basis because, of course, that database is shared with the different routers. However, you can have an import policy on the 5s to 7s, the externals, because they're moved in much more of a distance vector fashion between the different areas. So import policies for the 5s to 7s, the externals, yes, but the LSA 1s and 2s, that's not going to happen. Okay, so let's take a look at ISIS now, which is really where we're ending up. Well, firstly, ISIS has a similar issue to import policies because, of course, it's using a topological database and functioning in a similar way to OSPF. Now, prior to version 17, you couldn't have import policies, but today you can. However, we still have to be very careful. You can get yourself in a muddle on import policies from the database into the INET0. Okay, so let's have a look at some of the other unusual aspects of ISIS. Well, the first thing that's very unusual is that the routes are propagating upstream. What I mean by that is that in OSPF, which is a similar protocol, summaries are sent from the higher level to the lower level, or from the higher area to the lower area. This does not take place in ISIS. The level 1 area does indeed pass all of the data into the level 2 area. However, the level 2 area does not pass the data back. It also doesn't pass data from another level 1 area. So for example, if there's a level 1 area here passing into the level 2, that's not going to be passed into the level 1. And this takes a little bit of getting used to. In fact, it doesn't even pass in a default route. It sets the attached bit on the area border routers, then each router in the lower area has to generate its own default route. So that does take a bit of getting used to. However, the strangest thing about this is that externals going into the lower level 1 do not get passed to level 2. And this really is quite unusual because the level 1, of course, is going to the level 2, but the externals are not. How common is this? Well, really very likely. If you had an extra router here running, say, OSPF, on the one hand, you might think it would be better to connect your external router into the higher level to be as close to the core as possible. But in fact, it's much easier to inject your routes into a lower level where they can be filtered and dealt with and marked in particular ways and controlled. This is really very likely. So this is the one to watch, that there are no L1 externals being passed to level 2.